He is. Okay, number 11. Okay, so it gave you a big polynomial, right? It gave you a big polynomial, and it said p of x is equal to negative 0.00189 x cubed plus. What's your first thought when you see numbers like this?
Calculator.
Calculator. You better use a calculator, because is this something you're ever going to want to do by hand? Absolutely not, right? So there's your function. It says where x equals 0 represents which year? 1985. 1 represents 86, and so on. So it says use this function to figure out the approximate amount spent by Americans on foreign travel each year. So if I wanted to find 1985, what do I have to plug in for x? 0. So if I wanted b, which was the year 2000, what do I have to plug in for x? So 1986 was 1. 1987 would be 2. So you keep on going up, and then 2000 is going to be 15. So you do p of 15. So I'm going to show you a shortcut for how to do this cleanly on your calculator, okay? Everybody take out your calculator. It's going to plug 0 in for the value, hit enter. Oh, look what it comes out to be. Then I could go vars, go back to y vars, y1. What was that next? I want to do the year 2000. So what number did I have to plug in? 15, and you hit enter. Oh, look what I get. Is this a really easy way to evaluate polynomials? Yeah, especially if you evaluate it multiple times. What am I giving you a way to avoid? How did you do that normally on your calculator? You plugged the whole line in your calculator, right? This allows you to repeatedly, hand down for a sec, repeatedly evaluate the polynomial. So what was the next number we needed? 2006, what number do I plug in? 21. So it's going to be vars, y vars, and then instead of 15, I'm going to write 21 and hit enter. An even better shortcut, hold on, questions in a second, a better shortcut, if you do second and then the little negative sign, A and S. Does anybody know what happens when you hit enter? It puts the last, second entry. Second enter. Sorry. If I did one of these, so let me, it's being uncooperative, I'm sorry. Vars, y vars. So if I wanted to do 2011, what would I need to plug in? 2011, any ideas? 20 what? 26. So if I wanted to, it's going up, that should make sense. If I go second enter, it does the last entry. So if you have a really long line, you can get the calculator to call up the last entry. Sit down and see if you can duplicate these results. Sit down. A times 10 to the n. A is between what? 1 and 10, and n is a positive integer. Your final answer needs to be in this form. It's a good question, sure.
I guess my question is more on your comment. Oh yeah, I'm just not really sure what.
Actually, don't know what I was saying. This is the correct.
So it's right to something.
Yeah, I don't think it's right to something.
Okay, so
It's not in scientific notation. Correct. It's not in scientific notation. Does that form look like that? So write it in scientific notation. Yes, you do. Spend more than a couple seconds, then come up with a better question. And then except this is just. What does A need to be?
I don't know how to get this to be. No, I just so this has to be for myself. I know figure out which side.
Yeah.
So I know.
Why did the 4 go to 2? Where did the 4 go?
Okay.
What is the power of 4? Okay, kids, everybody stand up.
Many of you, stand up. Many of you have this. 1 over 4 times 10 to the 5th. This is equal to 1 over 4 times 1 over 10 to the 5th. Right? Are we good with that so far? Yes. That's equal to 1 over 4 times 10 to the negative 5th. Is it kind of looking like scientific notation now? What is 1/4 in decimal? 0.25 times 10 to the negative 5th. Don't write anything down. We're not done yet. Is that in scientific notation? No. Why not? It needs to be 2.5. But if we made that 10 times bigger, we need to make the other one 10 times. So it's going to be 10 to the
-6.
Done.
I thought we weren't allowed to have the negative.
It is scientific notation.
But in your thing, you said it has to be
In Oh, that's wrong. I'm sorry. N needs to be an integer. Sorry. Integer. That's a mistake. That is a mistake. It's an integer. You're absolutely right. That was a mistake. Calculators. What's a good first step? Yes. So what is 0.05?
5 times 10 to the negative 2.
Yes. And what is 1600?
1.6 times 10 to the third.
Yes. And this on the bottom becomes what?
4 times 10 to the negative 3.
Exactly. Multiplication can be rearranged. Multiplication can be rearranged. So what does this end up being? 5 times 1.6 times 10 to the negative 2 times 10 to the third all over 4 times 10 to the third. Negative 3, right? We can simplify the top a little bit. What's one thing we could do to simplify the top? What's one thing we could do? Yeah?
-2 minus -3.
So that means simplify that part. So we have 5 times 1.6 times 10 to the negative 3 plus what?
Actually, I was talking about the one in the bottom.
The one on the bottom.
Yeah, so you could...
Not yet. Not yet. I want to combine. What can we do on top first? Yeah. So what does it become? 10 to the what?
1.
Yeah. Negative 2 plus 3 is 1. So I'm doing a bunch of steps here. So it becomes 5 times 1.6 times 10 to the first over 4 times 10 to the negative 3. Now what can I work on? Yeah. So what do you have? 5 times 1.6 over 4 times 10 to the 1 minus negative 3, which is 10 to the what? 5 times 1.6 over 4 times 10 to the 4th. So what is that going to be? Well, you need to do this out. What's 5 times 1.6? 8 over 4 times 10 to the 4th. So what's that going to be? 2 times 10 to the 4th. Done.
Can you scroll up?
Yes. Right here. Revolves around this question. 2x plus 3 times 4x plus 9. FOIL! Excellent! I like that. FOIL. It's an okay word, but we're going to need to generalize. What does F stand for?
First.
Outer, inner, last.
Yes, and that's okay, but what I'd really like you to focus on instead, everything in the first term times everything in the second term. It's everything times everything. Doesn't matter what order you put it in. I like first, outer, inner, last, but I like making it more general because is it always going to be binomials that we're multiplying? It could be a trinomial. It could be more than 2. And does FOIL work? No, because you need a bigger acronym like first, middle, last, right? Just gets bigger. So if I were to do this, what are the pattern? There's 4 different multiplications you need to do. Let's do this one first. What's 2x times 4x?
8x
Squared. 2x times 9.
18x.
3 times 4x.
12x.
3 times 9. 27. Are we done?
No.
Because we can combine which 2 terms, Hannah?
8.
Yeah, that'll take.
Yeah, so you get 8x squared plus 30x plus 27. And now we are done. The next section is multiplying polynomials, which I know you've done a little bit of. So let's try another one. Let's say I gave you this. 2x squared plus 5x times negative x plus 9. Multiply that and simplify. What does this first one come out to, Kelly? Do you have an idea?
15x.
What did you get?
15x.
15? I don't know. Well,
Oh, he's doing it.
okay, hold on.
Okay, let me.
Oh, I see.
Negative 2x to the third
Yep.
minus 13x squared
Yep.
plus 45x.
Who got this?
Me.
Anybody else get that? So let's try it and see what happens. What's this times this? Negative 2x.
Plus 13x plus 13x.
Who got plus 13x?
Change that.
Yay! Nice. Woo! Okay, what about A, Alyssa? Yes. We will. I'm getting the answers first and then we'll take bids, okay? What about B? Yep. And there's a lot of things to keep track of here. What's 2 times 8? And then you have m to the second and m to the, so it's m to the 5th and then z to the 6th. All done. Now we can talk about these, now that you have seen them. Which one do you want to talk about? First one. What's 2 times negative x?
Negative 2x3.
Yep. 2x times 9. Or 2x squared times 9.
18x squared.
18x squared. 5x times negative x. Negative
5x squared.
5x squared. And 5x times 9.
45x.
So there's something you need to combine there, which, oh, these two. What do those become? 13. That's where it comes from. Is not touching the negative 4. So if it was negative 4a to the third, that means negative 4 to the third times a to the third. It's completely different. It's completely different.
What if the negative sign was on the outside?
Outside of the parentheses, like negative 4a to the third, like this, that would be different, yes. Depending on the a value. Just be careful. Just be careful. Okay. Okay, so you distributed it to where?
X.
Yeah, so it became 2x cubed plus 2x squared times x minus 3. You can do that. Now is it just 2 binomials? So what does it become now? 2x cubed times x is 2x to the what?
4.
And then you have this times that, a negative 3, not negative 3, negative what? 6x cubed. And then what's that?
Plus
2x cubed, right?
minus 6x squared.
Minus 6x squared. Now, are there things we can combine here? Yes. How many x cubes do we have?
Negative 4.
Exactly. Anything else we can combine?
Yep.
All done. All done. Multiplying polynomial in terms of notation.
No idea.
F times G is a function of X.
Yeah, it means f of x times g of x. So if you have f of x, what do you do with it if you have g of x? Multiply them together. That's all it means. It's the same exact thing. What about this? What does this mean? What does that mean? The same thing. It's just the different order. Does the order matter, though, for multiplication? No. There was one thing yesterday that touched upon on your homework that I want to make sure you understood. It's important, and we didn't go over it explicitly, but I want to make sure you did. Did you see this on your homework last night?
Yeah.
Yes.
What does that mean?
No.
It does not mean f times g, which is the key thing I need to make sure you understand. This right here is not multiplication if it's an open dot. And I give you the right to say that's a failing of math to use something that looks so much like a regular dot. Is there something going on? No. This means f gets g plugged into it. This means f gets g plugged into it. What do I mean by this? Let's say f of x was 2x squared plus 5 and g of x was x minus 3. Let's say I asked you for f of pi. What is f of pi going to be, Katie?
F of pi is going to be 2 pi squared plus 5.
Correct. And what's g of a going to be?
A minus 3.
Correct. It doesn't matter what I put in there. You're just plugging it in for wherever x is. So what does this mean? F of g of x. Sorry. What does this mean? What am I plugging in? Instead of x, what am I writing? G of x. And what is g of x? X, well, it's x minus 3. So what did I just do? I plugged g into, I'm not just pausing for dramatic effect, f. You're plugging g into f. What happens if I asked you this? Let's say I asked you instead, what about g of f of x? What am I plugging into what there? I'm plugging f of x into, what is g of x? X minus 3. But instead of x, what am I going to write, work?
Whatever it is.
F of x. And what is f of x?
F of x is the 2x 2 plus 5.
Plus 5 minus 3. Can I simplify that a little?
Yep.
2x squared plus? Simplify. Plus what?
Plus 5.
Minus 3 is?
2.
2. Yes. The idea is that
6x squared plus 8x squared plus 9x plus 7.
plus what?
7.
7? Where'd you get 7 from?
12.
12?
Yeah.
4.
4. Huh? I'm confused.
I didn't get that.
Okay, let's do this out. We need to do this carefully. What's 3x times 2x squared? Cubed. What's 3x times x?
3x squared.
3x squared. 4 times 2x squared? 8x squared. And this times this is? Are there things we can combine? 6x cubed plus 11x squared plus 4x. So that right there is f times g of x. That's what that is. The next part of this question asks, find like f of g of negative 1. So what does that mean you have to plug in? What'd you say? Negative 1. So it's going to be 6 times negative 1 cubed plus 11 times negative 1 squared plus 4 times. Simplify that for me. So what do we have here? Negative 6 plus 11 minus 4. So that's going to be 5 minus 4 is what? 1. Nice.